So that today is the last and final lesson that I'm going to show you on, sorry, I had to get a drink. The last and final lesson that I'm going to show you in pure math. It's actually typically what I do when we started doing finding the equation of a line, given that you have a derivative. And then last week what we did was area under a curve. And today what we're going to be doing is called volume of rotation. Actually, that is one big chapter, and I broke it into 3. So, hopefully, you guys, this will be your thing. So, volume of rotation. Okay. You're going to have to get your thinking caps on because you know my artistic ability is subpar, but I will do a lot of descriptive talking. I should teach English. We'll do a lot of descriptive talking and hopefully you'll get an idea of what these things look like. Alrighty? So the first task of this day is I'm going to have you draw y equals x squared, but I only want you to look at from x is 0 to x is 2. So draw that for me quickly on your piece of paper and then we'll go from there. So if I'm taking, did you guys make a drawing that looked as pretty as mine? Are we cool? Is everybody good? Yeah? Yeah? We know what x squared looks like from 0 to 2? Feeling good? Okay, so what I'm going to be doing is I'm going to take this two-dimensional drawing. Does everybody understand what I mean by two-dimensional? It's on the piece of paper, it's on the board. It's not three-dimensional. It's not something that could hold water, okay? So I'm going to take this two-dimensional drawing and I'm going to create a three-dimensional drawing out of it. Okay, so good luck to us. What we're going to do is we're going to take an axis of rotation, We're going to find an axis. And we are going to rotate our two-dimensional drawing about that particular axis. So get in your creative mind for 2 seconds and let's visualize, let's say the door that you guys all walked into. Let's say the door is on this pole that has the hinge on it. And let's say I take that door and I rotate it around there. We don't have a wall anymore. We start rotating it around. Do you agree that one panel of a door, as I rotate it around, starts to visually look something three-dimensional? It would actually kind of look like a can, a cylinder of sorts. So what we're going to do today is we're going to take that one singular panel and we're going to create something that causes it to look three-dimensional. So if I took this x squared from 0 to 2 and I rotated it 360 degrees. What do I mean by 360 degrees? I mean one full circle, right? So if I rotate it 360 degrees about the x-axis, okay? So I'm rotating it. When I say about an axis, that means it's fixed to that axis. It is not coming off that axis. As I start to rotate it about that axis, I am going to create, let's see if we could all do it visually, I'm going to create something that kind of looks like this. Not a very good picture, but you got the idea. Oh, bad picture. My perspective, my visual, like what I can liken it to, is a Hershey's Kiss, one that you get on Valentine's Day, that is a nice jumbo Hershey's Kiss, laying on its side. Do you guys see in that? So you got a Hershey's Kiss. No longer do you have like an Easter bunny that is hollow down the middle. You got this solid Hershey Kiss, full of chocolate. You guys cool with what I just said? All right? So, as I start to rotate this thing, it's going to come across, come there, go back through the wall, and come back up. There's my solid hunk of chocolate. Now, let's say I take this line, okay? This purple line. And as I start to rotate this thing around and back through, and then I take a knife, because I'm kind of like a sharing kind of girl, I'm going to take this thing and I'm going to cut it off, and then I'm going to hold it up to you all. I'm holding the point in my hand. What do you visually see in front of you as I took this off and held it up? You see a what?
Circle.
You see a circle. What color circle do you see actually? You see a purple circle. Do you agree? As this thing comes around, goes down back through, I have a circle. Now, having said that, what if I take this and also rotate it around, cut it, hold it up to you, what do you all see?
Red circle.
Red circle. Give me a little bit more description as compared to what we just saw.
Bigger.
It's a bigger circle, right? It's not only is it red, but so what's happening is as I rotate it, I'm going to cut it and then hold it up to you. Hershey's Kiss, cut, hold it up, you see a circle, okay? What about this one? I'm flipping it around, I'm holding it up, remember it's now three-dimensional, what do you see in front of you? I see a circle, but it's tiny, right? It's a little guy, it's a little circle, okay? So, what about this guy?
Big green circle.
You say a green circle, however, it's what? It's my largest circle that I could have there, do you agree? It's on the end, right? Okay, how many circles potentially could I have? I have an infinite number. I have an infinite number. I could cut as many little tiny itty bitty circles as I want, from smaller all the way up to bigger. Are you guys cool with what I just said? So, last week we learned how to find the area under the curve. This week we're actually going to find the volume. The volume brings it to a different dimension. So let me show you the formula for volume and then let's come back and discuss. The formula for volume is this. It is not given on your bright colored sheet of paper. It's one that we have to understand and know. Okay? I sound like an infomercial and that's my disclaimer. So having said that, if I peel back and get rid of that from A to B, what do I have up here? Pi r squared. What is pi r squared? What is the significance of pi r squared? It's an area of a circle. So I'm literally finding the area from A to B. What's my A and my B in this case? My A is 0 and to 2. I'm finding the area of every single potential little itty bitty circle that I could have drawn, and basically the integral is just going to add them up for me. Because you know, it sounds like a blast to find the area of the area of every single circle there. It's not possible because it's infinite. So this little formula takes care of that business. Are we cool? You understand the whole significance of the circle now, right? Having said that, last week I taught you the easiest way to figure out the area under a circle is do ceiling minus floor. It's the same thing here, guys. So if I'm looking at this guy living in this glorious house of chocolate, okay, here's my guy, your radius of each of those circles is going to be technically from the ceiling to the floor. Does that look familiar? So in this case, what would the radius of each of those little slices of circles be? What would the radius of it be? Well, it would be whatever x squared is minus, what's the floor in this case? 0. So my radius in this case is going to be pi, and then it's going to be x squared minus 0 squared. And what is my A and what is my B?
2.
And so we technically, in math world, we say the smaller guy first. So from what to what?
0.
From 0 to 2. So from 0 to 2. And voila, once we go ahead and do the actual math of this, we will have the volume of this solid piece of chocolate. Okay? So let's do the math of it. So what do we know about anything minus 0? It's just it, right? And what do we know? So let's slowly show our work. So we know it's just that. And what do we know about a power to a power? We multiply. So, and the one thing that people forget every time is that you have to kind of carry that pi along with you, bring it for the ride. Now I always say, who wants to forget pi? You know, because pi is kind of cool. But anyway, good to eat as well. So we're going to go from 0 to 2. I actually don't like pie. So what is x? I know, it's a travesty. Apple pie is the worst, if you ask me. So what's x squared to the, I know. But I do like chocolate pie, so if you all, no, never mind. So x squared, what do we got? X to the fourth. I have not done any kind of calculus yet. I've algebraed it, right? I've algebraed it. I always try to algebra it first. And now let's go ahead and dive into our calc world. What do I do? No, see that? People lost their head yesterday. Yeah, they lost their heads. There was heads getting lost. We have to integrate it first. I know, trust me. I was like, well. Okay, so x to the fourth becomes x to the over, yeah, from 0 to 2. Don't forget your pi, who would? You all love pi. Okay, now, plug in your 2, assess it from 2 to 0, just like we would have done yesterday. 2 to the 5th over 5, minus 0 to the 5th over 5. Don't forget your pi. So easy to forget pi. 2 to the 5th over 5 is 32, 32 fifths. Anything to the 0 to any power is 0, that's gone. Don't forget your pi, and you have the volume of that solid piece of chocolate.